more problems on the or say mixed problems on this differentiation topic, right? So I'll solve few problems today, and based on that, I'll give you the exercise which you'll have to complete. So let's start with the first question. So we have to differentiate this function, root of 3x plus 2 plus root of 1 divided by 2x square plus 4. Right. So if you see this, both of these are actually uh, polynomials to power half, right? Square root is nothing but something to the power 1 by 2. So let's differentiate this now. So both of them can be differentiated as usual. What we have to do is we'll just write them as, say, this is 3x plus 2 to the power 1 by 2, and the second function is 2x square plus 4, and because there is nothing in numerator, just 1, so I'll write it as to the power minus half. Okay, so this is our function y. So what will be y dash? So it is y is equals to some function raised to power n. So y dash becomes n into the same function to the power n minus 1, and then differentiation of that function, that is chain rule. So this will be half into 3x plus 2 whole to the power half minus 1 into differentiation of 3x plus 2, that is 3. That is the first half, and the second half minus half into 2x square plus 4 to the power minus half minus 1 into differentiation of 2x square plus 4, that is 4x. Right? So what do we get now? We get half into 3x plus 2 to the power minus half into 3 plus next one is minus 2x, this 2 and this 4, they cancel. So you have minus 2x into 2x square plus 4 to the power minus 3 by 2. Correct? So this can be simplified and written as 3 by 2. 3x plus 2 to the power minus half is nothing but root of 3x plus 2 in the denominator, then minus 2x in the numerator divided by 2x square plus 4 to the power 3 by 2. Right? So this was a very simple problem. Let's move to the next one. Now the next function is this y is equals to e to the power secant square x, then plus 3 cos inverse x. Now you should know all the formulas, right? That is differentiation of all trigonometric functions and all inverse trigonometric functions as well. So the functions or the formulas which we will need is that e to the power x, differentiation of e to the power x will be e to the power x, and differentiation of cos inverse x is minus 1 by root of 1 minus x square. So this we have to apply here. So y dash is, so e to the power x is e to the power x. So if it is e to the power some function of x, then you'll have to apply the chain rule, and it becomes e to the power that function of x into differentiation of that function. So this will be e to the power secant square x into differentiation of secant square x, then plus 3 into differentiation of cos inverse x, and differentiation of cos inverse x is simple, that is minus 1 divided by root of 1 minus x square. So this is the first function becomes e to the power secant square x into 2 secant x, and then differentiation of secant x. So differentiation of secant x is actually secant x tan x, right? And then minus 3 divided by root of 1 minus x square. So this becomes 2 secant square x tan x e to the power secant square x minus 3 divided by root of 1 minus x square. Right, so that is the second question. In this third question, the function is y is equals to log of x. But the thing is that outer base of log is 7. So that is log of x, but only the outer base is different. Inner base is not given, that means, and what did we say earlier? If nothing is given, that means this log is base e, right? And then we have the formula to change the base. So we should actually convert this whatever log, if the base is different, we should be able to change it to log base e. And then we have this formula for change of base, that is log, say, x to the base b. If this I have to change to some other base, say log x to the base a, then I have to divide it by log that base b. This formula I think you still remember. So the same formula we have to apply here, right? This formula you can remember like this or like this: log x to the base a. If I have to change it to base b, then log x to the base b into log b to the base a. So these two are the same formula actually, just cross multiplication we have done in the second step. Right, so same thing we have to apply here as well. This y becomes log, I have to change the base, so log of, inside there is no problem, divided by log of 7. Simple. So now y dash is this log 7 is a constant, so take it outside, 1 by log 7, that is, and it is to the base e, right? And then we have the function which we have to differentiate, that is log of x. So this is now straightforward, 1 by log x into log of anything, so d by dx of log of a function will be what? 1 by fx, and then differentiation of that function. That's what chain rule is. So this becomes 1 by log x, because this is the internal function fx, and then differentiation of that function, so that is 1 by x. So simplify it and write x log 7 log x. So this is your answer. Let's try another question. This function is y is equals to cos inverse of sin x. So just now we have seen d by dx of cos inverse x is equals to 1 by root of 1 minus x square, negative. That is minus 1 by root of 1 minus x square. So here it is cos inverse of sin x. So we'll have to apply the chain rule. Cos inverse of sin x is minus 1 divided by root of 1 minus sin square x, and then differentiation of sin x, that is nothing but cos x. Right? So this becomes minus 1 into cos x divided by cos x, and that is equals to minus 1. Now the same function can be done, or same question can be done in another way as well. So in this case our answer is minus 1. Let's see the other technique. This cos inverse of sin x, which is our function y, that can be written as cos inverse of cos of pi by 2 minus x. And what do we know about inverse trigonometry? Cos inverse of cos theta is equals to theta. So that means our function y is equals to pi by 2 minus x. And that's why y dash is equals to 0 minus 1 or minus 1. So what do we see here? In both the ways we got the same answer, that is minus 1. Right? So there are two ways of doing this. Both the ways are there on your screen. Right? Let's solve one more question now. Now here we have function fx is equals to sin x to the power sin x. And we have to find differentiation of this function f of x. So let's do it. Now this is the type of question which we have seen earlier, and functions like x to the power y or y to the power x, something like this. So we said that if something like this comes, what we should do is we should take logs on both the sides so that the exponents become product and it becomes easy for us to apply the differentiation rules or methods. So let us say this is y, which is equals to this. So that means if I take log on both sides, then log y is equals to sin x into log x. Sorry, sin x into log of sin x. So this is how, I mean, log x to the power y is equals to y log x. This is the formula or the property which we have used here. Right? So log y is equals to sin x into log of sin x. Now differentiate on both sides. So this becomes 1 by y dy by dx is equal to, you have to apply the UV formula. That is, first differentiate sin x, that is cos x, into the second function as it is. So that is log of sin x plus, now differentiate, now first function as it is, that is sin x, into differentiation of second function, that is 1 by sin x, because that is log of sin x, into differentiation of sin x, that is cos x. So this is 1 by y dy by dx is equal to cos x into log of sin x plus cos x, right? Or if I take this cos x common, it becomes cos x into 1 plus log of sin x, right? So that is 1 by y dy by dx. So we have to find just dy by dx. So that will be y into this. And what is y? Y is sin x to the power x. Sin x to the power sin x. So let us write that itself. So that is sin x to the power sin x into cos x into 1 plus log of sin x. So this is our answer, the last expression, that is this one, right? So again, a very important question. You should know this trick or the method. It's not that this question you have to remember. You have to remember, or you have to learn this trick. Okay, let's move to our next question. So here we have y in terms of t, that is y is equals to a to the power t plus 1 by t, and x is also in terms of t, that is t plus 1 by t to the power a. Now you have to differentiate this, and basically you have to find dy by dx, and a is constant. Constant is set so that we don't take it as variable and start differentiating with respect to a as well. So obviously this will be possible only if t is not in 0. Otherwise, if t is 0, 1 by t here and 1 by t in x both will be uh, not defined. So now how do we solve such problems? This is parametric form question. So first you differentiate with respect to t, both y and x, and then you divide them. So first find dy by dt, right? So this is in the form of a to the power x. So remember that becomes a to the power same thing into then differentiation of the, sorry, into yes, a to the power, this is in this form, right? A to the power x, then it becomes a to the power x log a. So this is log a, but this t plus 1 by t is a function, so that also has to be differentiated. So that becomes 1 minus 1 by t square. Remember this, this 1 by x, right? Dy dx of 1 by x is actually minus 1 by x square. So you can derive and prove it if you have forgotten this. Now that's what is dy by dt. It is a to the power t plus 1 by t into 1 minus 1 by t square into log a. That's all. Now what is dx by dt? So similarly we have to find dx by dt, and that is okay, t plus 1 by t to the power a. So that is the a into t plus 1 by t to the power a minus 1, right, into differentiation of t plus 1 by t, that is 1 minus 1 divided by t square. So when we have to find dy by dx, we have to divide these two, right? So dividing these two, that means this and this got cancelled. Correct? So by dividing this, what we have got is that particular thing got cancelled, that is 1 minus 1 by t square, that gets cancelled, and what we have is just this, a to the power t plus 1 by t into log a divided by a into t plus 1 by t whole to the power a minus 1. This is our answer. Let's try and see if we can solve one more problem in the time which we have left. Now, here we have this question is to differentiate a function, say sine square x, with respect to another function and not x, that is e to the power cos x. It is same as your parametric form. When you have to differentiate a function with respect to another function, you differentiate both the functions with respect to x and then you divide them, right? So first, let's say this function is u and this function is v. So first you find u dash. So u dash will be 2 sine x cos x, and sorry, this is v. V dash, that is this function's differentiation, will be e to the power cos x as it is, and then differentiation of cos x, that is minus sin x, and then the required differentiation which we have to find actually du by dv. So you just divide them, that is 2 sin x cos x divided by minus sin x into e to the power cos x. So this, what you will get finally, you will get minus 2 into cos x divided by e to the power cos x. Now this is something which you should learn whenever you have to differentiate a function with respect to another function. So this technique is very important. Now that covers this chapter, differentiation. We have done some problems as well. Now I will send you exercise problems of miscellaneous exercise of this chapter. Try to solve that and get back to me with your doubts whenever you have.